right, so we're going to look at image formation in a convex mirror, so one that is curved outward relative to where our object is located. But just like with a concave mirror, every curved mirror has these properties as if they were a sphere. That idea that the center of curvature would be the center of the sphere if I just cut this mirror out of a portion of that sphere. And of course, halfway between the mirror and the radius of curvature is our focal point. And those two variables are going to be important as we do mirror image formation with rays. So our ray tracing for image formation in a convex mirror. All right, so two principal rays we're going to focus on, no pun intended, in just a minute. There are two rays that are going to help us form that image. The first ray of light that we're going to pay attention to is the one that runs parallel to the optical axis. So I'm using the top of my arrow as the set point here, and I am drawing one of those rays from that top of the arrow is going to go parallel to the optical axis. That ray, based on the law of reflection, is going to be reflected in line with the focal point. Okay, so it'll be reflected off there. So as if that was in line with the focal point, that's our angle of reflection based on the law of reflection. Similarly, if I have a ray of light that is in line with the focal point, so these are a little bit harder to draw without a straight edge, but you can imagine if I just kept going here, oh, it'd be close. In line with the focal point, those rays of light are reflected out parallel. Now, these two rays of light are never going to converge. They're never going to cross paths so that where they cross path, the head of the arrow is recreated. However, they will hit my eye out here somewhere. We have our visual system. They'll hit the eye, and they're going to actually be the same rays of light as if they were coming from an entirely different object. So I've ray traced this one back. If I take this line and head it backwards, this object there, this image that we've formed, is the same rays of light as if there was an object right here hitting my eye. And so the image, this is our image formed visually that we make up, we perceive, therefore it is a virtual image. How do we also know it's virtual? It's upright. Our virtual images are always upright. And it's located behind the mirror. So, again, our principal rays that are important, parallel rays of light are reflected in line with the far focal point, or the focal point. Rays of light in line with the focal point are reflected parallel. These are never going to converge, but they would be the same rays of light as if I had an object where they intersect behind the mirror. It would be upright, therefore virtual. Now, if I move my object, anywhere I move my object, this image is always going to be upright and virtual. A convex mirror diverges rays of light, okay? And if I'm diverging those rays of light, I can never form an image. Similarly, it's always smaller. It is always going to be a smaller image, and I would encourage you to practice moving that object to see how the location changes slightly. It does change, but it is always smaller than the object and always virtual. Now, convex mirrors are really good. In our in the conceptual lecture about convex mirrors, we talked about how they spread rays of light around, how it gives us a wider viewing angle because those rays of light that represent part of that object are now hitting a wider range of locations, and therefore we can see around corners, for example. These are the types of mirrors that are used in hospital corners. That being said, we have to be very cautious about this wider range because we have smaller images, and so our brain perceives those images as further away. These are also the kind of mirrors that are used in a rear view mirror. A passenger side rear view mirror, and there's that warning in there that says objects in mirror are closer than they appear, because that convex mirror is giving us an image. It's widening our view with that blind spot, but it's creating an image that is smaller than the object. And our brain interprets smaller as farther away. So image formation can be super cool, and we have to be aware of what it's actually doing. So convex mirror, diverging, light rays are always diverging, always is going to make a virtual image, always going to be smaller. All right, good job.